Hello. So let's continue our work on Gödel numbers. So last time, we started to I explained about what Gödel number is. Uh, it's a unique natural number assigned to each English word or string. Actually, of course, we can uh, enhance it to accommodate any symbols as well. But anyway, today we are trying to do only upper cases from A to Z. So take the nth prime number and raise it to the power of k, depending on the character position n and uh, find the position of the alphabet. Uh, yeah, from A to Z. Okay, so that's the product of all these terms, the Gödel number. And then we started to look to make a function to compute the Gödel number. First, we made a list of prime numbers, and I explained how to calculate k. Okay, let's continue. So let's continue to define a function to compute Gödel numbers for the incompleteness theorem. As I explained, this was invented for the purpose of proof of incompleteness theorem, but that's all up to you to read all the story. So let's continue. So given a string, pair each character with its position index using enumerate. So let's do that. So, okay, let's go back. Let's continue from here. Okay, so we now have prime list. And yeah, let's check that. Prime list of, say, length 100. Okay, then, oops, of course, we have to rerun it. Okay, from here, rerun it and check that. Okay, so from here, given a string, let's try Japan. Okay, and then for each character, we need n. Okay, we need I to, yes, we need position n and we need the k number. So for n and c in range, no, enumerate is good to generate the index and also the term. So we take SS, just in case we have lowercase, we use upper function method to change it to all upper. Okay, and then we can calculate N and C like this. Okay, J is the index 0, A. So this is N. So, and at the same time, we can calculate K as we did last time. K is this one. Okay. So we calculate K equals ord C minus ord A plus 1. Okay. So K. And then we find the nth prime number, which is PL. P is PL of n. Okay. So this is all. Let's check that. As we see, Japan, the index is 0, prime number is 10, as we saw last time. Okay. J is 10th, 1, 16. So here, 10, 1, 16. And for each, these comes the prime number. Oh, I forgot to print P. Okay, so 2, 3, 5, 7, 11. So, as I explained, we calculate the compute nth prime and raise it to the kth power. And that's done by product term, as I say, as the word I used, term equal P raised to the power of K. Okay? So this is good. We can write it term. And at the same time, we do, okay, we can see that 2 to the power of 10 is 1024. Maybe we switch the order so that it's easier to understand. Okay, K comes here. So 2 to the 10th is 1024. 5 to the 16th is this number. 11 to the power of raised to the power of 14 is like this. So we multiply all terms together. So we can do it by initializing the answer as 1, and each time answer will be multiple equal term. And we also print ans to print the variable step by step. So this is actually the answer. Okay, lastly, we will print like if SS goes to ans. And since this is supposedly very big, we will use comma so that we can use it. Okay, let's take a look. Okay, so Japan, oh, sorry. We don't need this F. So Japan, consisting of 5 letters, is like this. Big number. How many digits does it have? Yeah, Japan. We can count the number of digits by taking the length of this number. So let's write it here. As, len, ans, digits. Okay. This should be again colon, comma. Okay, let's take a look. Something is wrong. Oh, I see. Okay, of course. To use len, we need to change it to string. Ha ha ha. Okay, this should work. So to check the length of a string, we change it to string. Of a number, we change it to string and take the length. So this number, which corresponds to Japan, which the Gödel number of Japan has 31 digits. Okay, very good. Let's try another example. Tokyo, for example. Change this to Tokyo. And, okay, this is the same, but much longer because, yeah, no A's, but O's and Y's. Y has this number, O has this number. So the product has 58 digits. The Gödel number for Tokyo has 58 digits. It's like this. Okay? Interesting. Monkey. Okay? We can try monkey. It's good that we have upper method applied here. So all the words, all the characters are changed to uppercase. And this is again calculated. The last one is Y, which has 13 raised to the power of 25, which is like this, So the product has 64 digits. Very long. Okay, so please take a look. Check yourself that this is correct. And yeah, try many things as you like to see how powerful or how big the numbers are. Okay, we use this to check the number of digits. So, homework. Yeah, that's all for the conversion part. So, homework is think about how to define the inverse function that reconstructs the original string given this number, Gödel number of something. Okay? Please define a function to compute from this number to monkey. Okay, that's homework for next time. See you next time. Bye bye.